So we are given this information in a table. So I think the table below shows a discrete random variable x. And then we have x values which run from 1 up to 5. And then probability of x equaling to a smaller x, where we have t 3/16, 1/8, 3t, then 3/2t. And then the first question, we are requested to find the value of t. And then the second one, we are requested to calculate the mean and standard deviation of x. So how are we going to approach that?
So I'm not sure.
You didn't attend last time's lesson?
No, I wasn't around.
As if I even sent the video in the group. Okay, you.
I'm not sure those videos, but I haven't watched it.
I think you need to find it and watch it. Okay.
Yeah.
So we all know that always summation of probability gives us a 1, isn't it so?
Mm-hmm.
Yes, so we are going to add these other ones, t plus 3/16 plus 1/8 plus 3t plus 3/2t, and we equate this to 1. So you can add the like terms, 3/16 plus 1/8.
That is 16.
What does it give?
3/16 times 1/8.
Plus 3/16 plus.
Or plus 1/8. That is what I get.
Do you have a calculator with you? Okay, 3/16 plus 1/8 would give us 5/16. Then we are now going to add 1t plus 3t, that gives us 4t. So we are going to get 4.
Sorry. Proceed. That's a mistake.
So that would give us 11/2t. Is it what you are getting?
Clarify.
Then later there we are going to transfer the 5 over 16 to the right hand side. So we shall have 11 over 2t, giving us 1 minus 5 over 16. So 11 over 2t is going to be, so we put this over 1, so we shall have LCM of 16. So 16 divided by 1 is 16 times 1, so we shall have 16 minus 5. So 11 over 2t is going to be equal to 11 over 16. So we can do the cross multiplication. So our t is going to be equal to 11 times 2 divided by 16 times 11. So the 11 one is going to cancel out, and here by 1 by 8. So our t is going to be 1 over 8. Are we okay up to that point?
Yeah.
Okay. Now after getting that, we are going to substitute. Okay.
Yes.
So if we because now we have found the value of t, and then now we need to find the mean. So for the mean, we are going to use the formula. So mean is given by summation of x. We multiply that by probability values. So we are going to create a column for x, then times probability. So let us fill this table now. So we are going to get 1 times t, which still gives us t, but we have seen the t. If we wanted, we can substitute. So 1 times 1 over 8 will give us 1 over 8. Then 2 times 3 over 16. So we shall have 6 divided by 16. Then 3 times 1 over 8, it will give us 3 over 8. Then 4 times 3 over 8 will give us 12 over 8. Then 5 times 3, that would be 3 over 2 times 1 over 8. So it will be 3 out of 16. So this would be 3 out of 16. Then we multiply that by 5. So when we multiply that by 5, we shall have 15 over 16. Then after we add up these ones, so we add using a calculator. So what did we get when we add? So when we add here, we get 3.3125, which we can say is 3.3. So that would be our mean. Then after calculating the mean, maybe we would take this to the next. So we have x runs from 1, 2, 3, 4, 5. We have probability of x equal to a smaller x. And then now, since we are going to find the standard deviation, which is root of variance, we need to create a column x squared times probability. So this was 1/8. 2 is 3/16. This one as well is 1/8. Then 3/8 and 3/16. So we have already seen that our mean is approximately 3.3. So we are now going to get x squared, then we multiply by the probability of x equaling to small x. So 1 times 1/8 . Joel, 1 times 1/8.
1/8.
1/8. 2 squared is 4 times 3/16.
3/4.
3/4. Now let's leave it as 12/16 to make our computation is much easier. Then 3 squared is 9 times 1/8. So this would be 9/8. Then 4 squared is
16
yes.
times 3/8. That is 56.
40. 16 times 3.
16 times 3, that is 48/8.
Then 5 squared times 3.
That is 75. 75/16.
So we are now going to first get expectation of x squared, which is the same as summation of x squared times probability of x equaling to a small x. So this would be the same as 1/8 plus 12/16 plus 9/8 plus 48/8 and plus 75 divided by 16. So what do we get when we add those?
We get 203/16.
Divide by 16. And then, okay, so we could leave it to that. So then we come to our variance, which is expectation of x squared minus the mean. So minus the mean squared. So this would be 203/16 Then we subtract the mean. Let me get the exact value here. The mean was 3.125. 3.3125.
Your main meeting. Some background noise.
So what would be 203/16 minus 3.3125 squared?
Pardon, sir.
What is this? 203/16 minus 3.125 squared.
So 203.
Yes. I see Joel has given us 439/256. Are you getting the same answer, Alvin?
I'm calculating.
Okay.
I'm getting. I'm getting. Yeah, it's the same.
It's
So
the same.
439 over 256.
Yes. So remember, we wanted the standard deviation. So this would be root of 439/256. So you can get the root of that answer.
One point three one.
1.3.
1.31.
You've rounded off. Because I see Joel has 1.3095.
Oh, I have rounded off.
It's okay as well. Okay, let me get another one here. So Alvin, have we now tried to have a picture of what we had covered last time?
Yeah.
So another one, I'm just going to draw a table for it. I think the 4 are enough. So we have the X value, then we have probability. Then we shall need to find expectation. So we need as well to have X squared times probability. And then X squared, the above one here should be X just times still probability values. So we have -2, 0, 1, and 4. Then the probability values are 0.4, 0.1, 0.3, and 0.2. So we need to find expectation of X. And then also need to find variance of X. So what are we going to do for expectation?
Teacher, we are going to deal with this. We are going to multiply the X into the probability to get the expectation, and whereas to get the variance, we shall get the expectation minus the E of X squared.
Okay. So what is -2 times 0.4?
0.8, -0.8.
Then 0 times 0.1. That will automatically give us 0. 1 times 0.3, it remains the same. Then 4 times 0.2,
Still 0.8.
0.8. So for expectation, we are going to add this one. So we shall have -0.8. We add 0. We add 0.3. And then 0.8. So what would be our answer?
0.3. So the answer is C.
So the answer would be 0.3. So our expectation would be 0.3. Then for our variance, we would need to first have expectation of x squared. So this would be summation of x squared and probability of x equaling to smaller x. So we come here, we say -2 squared. What is -2 squared? Four. Then times 0.4.
That is 1.6.
1.6. This one would remain as 0. This one still would remain as 0.3. Then 4 squared. 4 squared is 16. So what is 16 times 0.2?
3.2.
3.2. Okay, so we are going to add those. So 1.6 plus 0 plus 0.3 plus 3.2. So what would be the answer here?
Four point five.
4.5. Then we are going to shift. So here where we have expectation of x squared minus expectation of x, then this one squared. So this would be 4.5 minus 0.3 squared. So what would that be equal to?
$4.41.
Final answer?
Yes.
4.4, 4.41. Then something we also need to do there, because time is also running up. In case we are told to find probability, here in a discrete, it is very simple. So if they need probability of x equaling to 0, you'd say this is just 0 point, 0 point what? 0.1. Is it okay?
Yes. So how about using the other table? There is a certain table which we use.
The second table.
No, the mass table.
I'm not sure whether it does this, but I'm going to check. Okay. But for discrete, I think for discrete we don't need the table. For discrete, we don't need the table because the values are already here. So they may ask for probability of x greater than 0. So for this case in our table, which numbers are greater than 0?
1 and 4.
1 and 4. So we'll say this is probability of x equaling to 1 plus probability of x equaling to 4. Then we say this is 0.3 plus 0.2, and this would be 0.5. I think the probability finding probabilities isn't a very big challenge under discrete. Then in case of mod, so for mod we choose the value of x that has the highest probability. So that gives us the mod of a discrete random variable. So for this case, what would be our mod? Which value of x has the highest probability?
4.
4.
Let me see.
I think it's not a 4. The one that has the highest probability. What is that value?
Teacher 4.
But the probability is 0.2. 0.3 is higher than it, and 0.4 is higher than it. So we look for the value of x that has the highest probability value.
So meaning it is negative.
Yes, yes. Is x equaling to -2. So for mod, we look for that which has the highest what? Probability. Is that clear?
How about the median?
The median, I'm going to record some short video about it because we have limited time here. Or we can begin with it next time next week when we are, I think, going to some other topic. But it is just something simple. I'm going to record the video, then I send it on the group. Okay. Otherwise, for today, we are stopping here.